In this video, we will learn to evaluate an inverse trig function to find a special angle or a quadrantal angle. When I say special angle, I'm talking about multiples of pi over 3, pi over 4, or pi over 6. Quadrantal angles are multiples of pi over 2. Alright, they're angles that fall on the x or y axis. Now, before we go any further, remember, you should be able to write down all 9 of these values on a sheet of scratch paper before you begin any trig test. I've colored these 3 in yellow because these were the 3 that you really just had to memorize. But once you memorize these 3, you should be able to get all of the rest of these white ones. Alright, because the cosine of pi over 4 is the same as the sine. These two are just the crisscross. Alright, so the sine of pi over 3 is the same as the cosine of pi over 6, and the cosine of pi over 3 is the same as the sine of pi over 6. So you get those. And of course, for the tangent function, tangent is just sine over cosine. So if you just divide these, then you get these. Alright, these cancel out and give you 1. When you're looking at this, you're thinking, oh, the denominators will cancel out, so forget about the 2's. I have 1 over radical 3. Over here, forget about the 2's. I have radical 3 over 1, which is radical 3. So you memorize the yellow ones, and you wind up knowing all 9. And you should just write them down on a sheet of scratch paper as soon as you sit down to take a test. So let's imagine that you've done that. In fact, you should pause the video right now, walk away from the screen, and take out a sheet of scratch paper and see if you can write down these 9 things straight from your brain. In fact, if you can't, you should do that exercise over and over again until you can. So for the rest of this lesson, I'm going to refer back to this. Both of these are examples of inverse trig functions. Alright, tangent with a little -1 on it, inverse tangent, would be the same thing as arctangent of radical 3 over 3. Alright, these are the same thing. Now, there's a couple of other things I need to point out. So, first of all, inverse trig functions are angles. Okay, when I give you an inverse trig function, I'm saying what angle would have this as the answer. So this is basically saying, okay, the tangent of what angle is equal to radical 3 over 3. And this one is saying the cosine of what angle is equal to 1/2. So you're looking for the angle. So it's made slightly tricky by the fact that there are different forms of this, and I've been giving you the form that said 1 over radical 3. But 1 over radical 3 is the same as radical 3 over 3. Alright, in the same way, 1 over radical 2 is the same thing as radical 2 over 2. So you really have to recognize these as being the same. Okay, so understanding that these two things are the same thing, what angle gives you a tangent of radical 3 over 3? What angle gives you a tangent of 1 over radical 3? If we look back at that chart, okay, looking at the tangent zone, you see we have 1 over radical 3 right here. Okay, so tangent of pi over 6 gives you 1 over radical 3. So pi over 6 is what we're looking for. But here's the tricky part. Pi over 6 is just a reference angle. So we've narrowed it down to a reference angle of pi over 6. The truth is there will be 2 answers, and it's possible that one of them is pi over 6, but it's also possible that there will be 2 completely different answers. The only thing for sure is that pi over 6 is the reference angle. Alright, let's look at a sketch on a unit circle. Alright, so here is a unit circle. Since the reference angle is pi over 6, I am going to draw some pi over 6's. Okay, so these are going to be pi over 6's. See how there are 6 slices in the top? That means each one is pi over 6. So here's the thing, reference angles, people. There are 4 angles, there are 4 positions that all have a reference angle of pi over 6. Okay, any of these 4 angles that I'm indicating here would give me a tangent of radical 3 over 3, or 1 over radical 3. But 2 of them will be positive radical 3 over 3, and 2 of them will be negative. Notice how this is positive. There's no negative in front. So we need the 2 of these that will give us a positive answer. Let's see. Tangent is positive in the first quadrant and the third quadrant. That means this and this will be my answer for this problem. Okay, so one of the answers is in fact pi over 6. Alright, now the other one is, let's see, 1, 2, 3, 4, 5, 6, 7 pi over 6. And that's how you do it. Alright, let's look at that again for number 2. Alright, again, arc cosine of 1/2 means what angle has a cosine of 1/2, alright? So you should be thinking this in your mind. Cosine of what angle is 1/2? Well, look at your scratch paper. Okay, where do you see 1/2? I see 1/2 right here. Cosine of pi over 3 is 1/2. So be careful. That just tells me that pi over 3 is my reference angle. So I've got a reference angle of pi over 3 to start me off. Now let's go ahead and draw the diagram. And since the reference angle is pi over 3, I'm going to draw some pi over 3's. Alright, see how there are 3 in the top half? That means each one is pi over 3. Now, in terms of reference angles, there are 4 positions that will give me a cosine of 1/2. They are here, 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 and here. Except for 2 of them will be positive and 2 of them will be negative. Notice how this is a positive 1/2. So I need the 2 of these that will have a positive cosine. Well, remember that cosine is an x value, and x values are positive over here to the right. So these are the 2 positions that will give me a positive 1/2. Okay, so the first one is simply pi over 3. But the second one is, this is 1 pi over 3, 2, 3, 4, 5 pi over 3. Okay, let's do that again for number 3. Alright, so remember, arcsine, well, first of all, pause the video and try to do this by yourself. I've done 2 problems for you. Time to take off the training wheels. Pause the video and try to do this by yourself. So this is asking the question, sine of what angle is equal to 1/2? So let's look at our scratch paper. So here's sine, and here's 1/2. So that's sine of pi over 6. So be careful, that's not the final answer, that's just the reference angle. So far we know that the reference angle is pi over 6. that tells us enough information to draw a sketch of our unit circle. And since we know the reference angle is pi over 6, we will draw some pi over 6's. Okay, but there are 4 positions that will give me 1/2. They are the 4 spots that have a reference angle of pi over 6. Alright, above and below the x-axis. These lines are not very straight, but you get the idea. But 2 of these will have a positive sign, and 2 of them will have a negative sign. See how this is a positive 1/2? So we need the 2 that are positive. The sine function is a y value, so it's going to be positive above the x-axis. So these are the 2 angles that I really want. Now one of them is pi over 6, but the other one is 2, 3, 4, 5 pi over 6. Okay. Let's do it again for number 4. Alright, this one is interesting because now it's negative. Again, pause the video please and try to do this problem by yourself. Alright, arctangent is asking you the question, the tangent of what angle is equal to negative radical 3? Let's start by finding the reference angle. Let's look at our scratch paper. Well, here's radical 3 right there. So that tells us the tangent of pi over 3 is radical 3. So that's our reference angle. So let's write that down. So our reference angle is pi over 3. Alright, let's draw a sketch showing pi over 3. Alright, see how there are 3 slices in the top? That means they are pi over 3. Now, there are 4 positions that will give me some kind of a radical 3. Alright, it's all 4 of these actually, because they all have a reference angle of pi over 3. But 2 of these will have a positive tangent, and 2 of these will have a negative tangent. This time, I want the ones that are negative. Hopefully by now you have memorized that tangent is positive in the first and third quadrant, but it is negative in the second and fourth quadrant. So these are the 2 that I want, because these are the 2 that have a negative radical 3 for a tangent. Okay, so what are these things, you ask? Well, counting from here, this is 1, 2 pi over 3. Three, 4, 5 pi over 3. So there you go. Alright, I'm going to start trying to do these as fast as I can. I did a few of them very slowly, and hopefully now you understand. So picking up the pace, this is saying that the cosine of what angle is equal to negative 1/2. Well, let's start by finding the reference angle by looking at our scratch paper. So we got cosine, and there's 1/2. So the reference angle is pi over 3. Okay, so if we look at a sketch real quick. Okay, there are 4 positions where cosine is going to give us 1/2. Those 4 positions are here, 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 and here. But 2 of them are positive and 2 of them are negative cosines. We want the negative ones. Cosine is negative to the left of the y-axis, so here and here. That's why the two answers are going to be, let's see, 2 pi over 3. Okay, for this one, 4 pi over 3 for that one. Okay, number 6. This is asking us the question, sine of what angle is equal to radical 3 over 2? Let's look at our scratch paper. Sine radical 3 over 2. The reference angle has to be pi over 3. Okay, so the reference angle is pi over 3. Let's make a sketch. Okay. So these are the 4 positions that will give me some type of radical 3 over 2. But we need a positive radical 3 over 2. The sine function is positive above the x-axis. So those are the 2 that I need. So this first one is simply pi over 3. And the second one is 2 pi over 3. Alright, look at number 7. This is asking us the question, cosine of what angle is negative radical 3 over 2? Let's start by finding the reference angle. Okay, cosine has to be radical 3 over 2. Look at your scratch paper. Cosine, radical 3 over 2, that's pi over 6. Cosine of pi over 6. So that's my reference angle, is pi over 6. So we do the sketch. We're sketching pi over 6's. Okay. Now, all 4 of these have a reference angle of pi over 6. So they will all give me some type of radical 3 over 2. We need the 2 that are negative. Cosine is negative to the left of the y-axis. So these are the 2 actual answers. And those are 1, 2, 3, 4, 5 pi over 6. 6, 7 pi over 6. Alright, how about number 8? Alright, look at number 8. This arctangent business is asking us the tangent of what angle is 0. Now, this is not one of the ones on our scratch paper. There's no 0. But it is a quadrantal angle. So, what am I talking about? Gibberish. If you look at our unit circle, then what we have is we've got these quadrantal angles that, you know, the terminal side would fall on the quadrant lines. So this is the point 1 comma 0. This is 0 comma 1. This is negative 1 comma 0. And this is 0 comma negative 1. Now, remember that tangent is sine over cosine. And remember that sine on the unit circle is a y value, cosine is the x value. So what we're looking for then is a y value divided by an x value that equals 0. Well, the only way to get 0 out of a fraction is if the numerator is 0. So basically the y value needs to be 0. So let's take a look around. Y value is 0 here, y value is 0 here. So these are the 2 angles that satisfy this little equation. So one of them, we can either, this first one, we can either call it 0 or we could have called it 2 pi. Okay, depending on which way you look at it. But the other one is pi. So 2 pi and pi, or 0 and pi, either way. Anyway, moving on. Number 9. Okay. Again, this is asking us the question, the tangent of what angle is equal to -1. Okay, now looking at our scratch paper, we see the tangent of pi over 4 is 1. So that gives us a reference angle. Okay, so we know the reference angle is pi over 4. So we should draw pi over 4. These are pi over 2 so far. Okay, now they are pi over 4. So there are 4 positions that will give me a tangent of 1, except for 2 of them are +1 and 2 of them are -1. We need the 2 that give us -1. Tangent is positive here and here, but it is negative here and here. Okay, so those are the 2 answers that we actually need. Remember that we are dealing with pi over 4. So this is 1, 2, 3 pi over 4. 4, 5, 6, 7 pi over 4. So that's the answer to number 9. Okay, number 10. This is asking the question, the sine of what angle is equal to 0? Again, 0 is not one of the things on our scratch paper. So it's going to be a quadrantal angle. So here's the sketch. So these are the 4 quadrantal angles. The coordinates are 1, 0, 0, 1, -1, 0, and 0, -1. So sine is a y value, so we need the y value to be 0. So that is here and here. Alright, it's just like another problem we did. So this one over here, we call this pi, and this one back here, we call it 2 pi. Or we could have called it 0. Okay, so that's the answer. Well, those are the answers, plural. Let's look at number 11. Arctangent. So this is asking us the question, tangent of what angle is equal to radical 3? Let's look at your scratch paper. Here's radical 3. Tangent of pi over 3 is radical 3. So that gives us the reference angle. So our reference angle is pi over 3. Alright, let's look at the sketch. We're doing pi over 3, so let's draw some pi over 3's. Okay. There are 4 positions that will give us some type of radical 3. It's all 4 of these. 2 of them will give us a positive tangent and 2 of them will give us a negative. The 2 that give us a positive tangent are here and here. So those are the 2 actual answers. So we're talking about pi over 3 and let's see, 2, 3, 4 pi over 3. Alright, look at number 12. This is asking us the question, tangent of what angle is equal to 1? Well, look at our scratch paper. Tangent of pi over 4 is 1. So that gives us the reference angle. Okay, let's do our sketch. We're sketching pi over 4s in honor of the reference angle. Okay, so remember, there are 4 positions that will give me a tangent of 1. Well, not exactly, because 2 of them will be positive 1 and 2 of them will be negative 1. So where is tangent positive? Because this time it's positive. Tangent is positive here and here. So that means our actual answers will be pi over 4, 2, 3, 4, 5 pi over 4. This is asking the question, sine of what angle is equal to negative radical 2 over 2? Now understand that radical 2 over 2 is the same thing as 1 over radical 2, which is what we usually write. Let's look at our scratch paper. Alright, so here's 1 over radical 2. That means the reference angle is pi over 4. Okay, so let's draw the sketch. So there are 4 positions that will give me some kind of 1 over radical 2, which is the same as this. I need the 2 that will give me a negative. Sine function is negative below the x-axis, so here and here. That means the 2 answers that I need are 1, 2, 3, 4, 5 pi over 4, 6, 7 pi over 4. Alright, look at number 14. Uh-oh, they're going crazy on us. They're doubling up. They're nesting these. So let's just do one part at a time. So ignore the cosine aspect of this. Let's just figure out what angle this is. Okay, so we need, so this is asking us the sine of what angle is equal to 1/2. Well, this is one of the ones that we have memorized. Sine of pi over 6 is 1/2. That gives a reference angle of pi over 6, so we draw the pi over 6's. Now, these are the 4 positions that will give me some sort of a 1/2, you know, because they all have a reference angle of pi over 6. But we need the 2 that will give us a positive. Sine is positive here and here, so those are the 2 that I need. Alright, so that's pi over 6, and it is, let's see, 2, 3, 4, 5 pi over 6. Okay, now I'm going to need the space back. Now it's time to go back and perform this. Now we're supposed to find the cosine of each of these. Okay, so maybe I should not have erased that picture. Okay, I brought the picture back. We need to find the cosine of this. So I need to find the cosine of pi over 6, and I need to find the cosine of 5 pi over 6. I'm missing that part. Alright, well, the cosine of pi over 6 is radical 3 over 2. Okay, that's right off our scratch paper. Right, the cosine of pi over 6 is radical 3 over 2. That's one of the ones we memorized. And it's in the first quadrant, so it's positive, so that's good. Now, the cosine of 5 pi over 6 based on the reference angle, it's also going to be radical 3 over 2. However, 5 pi over 6 is in the second quadrant where cosine is negative. So we're actually going to get a positive radical 3 over 2 and a negative radical 3 over 2. So I guess if we wanted, we could have written the answer this way. We could have written the answer as plus or minus radical 3 over 2. And maybe we can automatically know that from the reference angle. Once we get that reference angle of pi over 6, is it automatically going to be plus or minus radical 3 over 2? You know what? I don't think that's always going to be true. So let's look at the last one. I'm sorry, did I say the last one? It's not quite the last one. There's two of these. Now essentially these are going to undo each other, and I'm going to wind up with 11 pi over 6. Alright, I see that the reference angle is pi over 6, so I'm wanting to draw some pi over 6's so I can see what is going on. Now, 11 pi over 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pi over 6 is right here. So, what is the sine of 11 pi over 6? Well, starting with the reference angle, I know that the sine of pi over 6 is 1/2. Right? We wrote that down right there. But in this quadrant, the sine function is negative because it's below the x-axis. So instead of just putting 1/2, I'm going to put negative 1/2. So that tells me that this, all this right here, has a value of negative 1/2. Alright, that's the sine of 11 pi over 6 is negative 1/2. Okay, so basically now the problem has become, so I'm doing the inverse sine of negative 1/2 now. Well, as we've discussed, this is asking the question, the sine of what angle is going to give me negative 1/2? Now, we already know from what we've done that the reference angle is pi over 6. So let's skip to the part where we say there are 4 angles that will give me some type of a 1/2. They are here, here, and here. But we need the 2 that are going to give me a negative sign answer. So, of course, one of them is here, which we knew. Because that's our 11 pi over 6. But another one is here. So we have these 2 answers to write. And they are so starting with this one, that's 1, 2, 3, 4, 5, 6, 7 pi over 6. 8, 9, 10, 11 pi over 6. Alright, that 11 pi over 6 we knew from the beginning. Okay, but we didn't know the 7 pi over 6, so we had to go ahead and do a little bit of extra thought there. So, similarly here on number 16, the inverse cosine and the cosine sort of cancel each other out, and so I'm expecting to have one answer of 4 pi over 3. But what will the other answer be? So let's check it out. Clearly the reference angle is pi over 3. So let's draw that. So these are pi over 3's and 4 pi over 3. So 1, 2, 3, 4 pi over 3 is right here. Okay, cosine is negative in this quadrant. Now, dealing with a reference angle of pi over 3. Okay, let's look at our scratch paper and find out what the cosine of pi over 3 is, first of all. So let's see, cosine of pi over 3, remember, is 1/2. So we're thinking 1/2, except for, like I said, in the third quadrant here, cosine is negative, so therefore negative 1/2. Okay, so that's telling me that the value of this right here is negative 1/2. All right, again, I focused on the reference angle. I did the cosine of that, but then I had to put a negative on it because of the quadrant where it falls. So that turns this original problem into this new problem. And the new problem is, okay, the inverse cosine, whoops, not quite writing that correctly. I feel like using a different color anyway. I'm going to use this gray color. So, inverse cosine of, and now here I have negative 1/2. That's what I've got so far. But again, this is asking the question, cosine of what angle is equal to negative 1/2? Well, we already know one of them, don't we? Because of the way we chose it. But the cosine of pi over 3 is going to be 1/2. Okay, so there are actually 4 angles that will give us some type of a 1/2. They are all 4 of these, because they all have a reference angle of pi over 3. All 4 of these will have a cosine of some type of 1/2, but 2 of them will be positive and 2 of them will be negative. I need the 2 that are negative because of this. So the 2 that are negative will be here and here, because cosine is negative to the left of the x-axis. Sorry, to the left of the y-axis. So these 2 will be my final answers. So that is going to be 2 pi over 3 and 4 pi over 3, which we knew from the beginning. Okay, that is a really long video.